Hey everybody, welcome back. We're continuing our vector calculus. Let's just summarize all the rules for derivatives and integrals for vectors. Thankfully, if you know all the rules for basic functions, vector functions are no different, other than they're vectors now rather than just functions. So the derivative of a constant vector is the zero vector. Constant derivative of constant used to be zero, or still is zero. We did the constant vector, it's now just the zero vector. If we have a constant times a function, or in this case r, we can factor the constant out, pull k out, and just do the derivative of r by itself. If we have the derivative of two functions, either added or subtracted, we can distribute the derivative to each of them separately. So the derivative of r1 plus r2 is the derivative of r1 plus the derivative of r2. The same goes with the minus function or the subtraction. We have three forms of multiplication, product rule. We could do a scalar times a vector function. So scalar function times a vector function. F is the scalar function. R of t is the vector function. Remember our product rule, we got to do the derivative of each one at a time. I like to go left to right. I know the books tend to teach doing the derivative of the second one first. I think that's lame. Doesn't make sense to me. I go left to right. So I'll do the derivative of f first, leaving r alone. And then I'll leave f alone and take the derivative of r. That's our first version. Then we have two other forms of multiplication with vectors. We have our dot product. Same process though. You distribute the time derivative and you got to do it one at a time and add them up. We're doing the product rule, but with now it's dot product between each of the two parts. And the same goes with the cross product. So the derivative of r1 cross r2 is the derivative of r1 crossed with r2. And then added to r1 crossed with the derivative of r2. Those are our basic derivative rules. Let's take a look at our integration rules. When we take the integral of a with the limits of a and b of a full vector, it's the same thing as doing the limit for those same values for each of the components. So I've got the I hat component integrating x of t dt. The j component is integrating y of t dt. And integrating the z component is z of t dt. So integration is done component-wise, just like we did with derivatives. If we have a scalar or a constant times the vector function, we can pull the constant out. If we have the integral of two different functions, either added or subtracted, we can separate it into two integrals. The good old where the derivative and the integral cancel out. The time derivative of the integral of r of t dt is just r of t. If we do not have limits of integration on it, we have to add a constant. That was true with f of x. It was f of x plus c, or big f of x plus c. Shit, that's what I need to do right there. That should be big r of t. Not just the same one. Just like we have here, if we have the actual limits on it, we do r of t evaluated from t equals a to t equals b. Our fundamental theorem of calculus, r of b minus r of a. Those are the integration rules, derivative rules. That's it. Peace.